Hello everybody, in this video I will show you how to find the first derivative for algebraic function y equals to ax to the power of n. You can refer to Additional Mathematics Form 5 textbook on page 38 until 40. Okay, here I will going to derive the formula of differentiation for the function y equals to ax to the power of n, where a is a constant and n is an integer. Okay, look at the table here. So the table shows the function and dy dx obtained by using first principle. So it seems to follow a pattern as shown in table. Okay, from the given pattern for the function y equal to ax to the power of n, where a is a constant and n is an integer, we can deduce the first derivative formula for the function as follows. So we have a function y equals to ax to the power of n. So to find dy dx, by using the pattern, so equals to, so put n in front of a, you get na, and then x the power minus 1. So you get this one, or also this one. So that means dy dx or d dx for ax to the power of n is an x to the power of n minus 1. Okay, there are three notations used to indicate the first derivative of a function y equal to ax to the power of n. As follows. Okay, if y equals to 3x squared, then dy dx equal to 6x. So in this case, dy dx is read as differentiation y with respect to x. Second notation, if fx equal to 3x squared, then f prime x equal to 6x. So in this case, f prime x is known as the gradient function for the curve y equal to fx, because this function can be used to find the gradient of the curve at any point on the curve. And the third notation, d dx in bracket 3x squared equal to 6x. Okay, if differentiating 3x squared with respect to x, the result is 6x. The process of determining the gradient function f prime x from a function y equal to fx is known as differentiation. The gradient function is also known as the first derivative of the function, or the derived function, or differentiating coefficient of y with respect to x. The derivative of a function with contained term algebraically added or subtracted can be done by differentiating each term separately. That means if fx and gx are functions, then when you differentiate with respect to x, fx plus or minus gx, we get, okay, we separate, that means differentiate with respect to x, fx, plus or minus differentiate with respect to x, gx. To make it very clear, so look at the example here. We are going to differentiate each of the following with respect to x. We are going to find dy over dx or f prime x. Notice here the formula we will use, dy dx equals to an x to the power of n minus 1. So look at for question A. So we are going to find for the function y equal to 5. Because this function has no x and 5 is a constant, so actually dy dx for this case, okay, we are going to differentiate y with respect to x because there is no x, so of course equals to 0. So that means when we differentiate any constant, dy dx equals to 0. Okay, for B, okay, the function is y equal to 7x. Y equals 7x, that means y equals 7x to the power of 1. So to find dy dx equals to, so the power put in front, this one put in front, times 7 x power of the power minus with 1. So you get 7 x power of 0. X power 0 is 1, so equals to 7. So for C, the function is y equal to 3x to the power of 4. So to find dy dx, so use the formula given below. Put 4 in front, times 3 x the power 4 minus with 1. You get 4 times 3 is 12 x to the power of 4 minus 1 is 3. Okay, look at the example D. You're given the function y equals to 3 over 4x to the power of 8. So before we differentiate y with respect to x, we have to simplify using law of indices. Make x as numerator. You get y equals to 3. So bring x power 8 above, you get x power of negative 8 over 4. And then we can differentiate, find dy over dx equals to, bring negative 8 in front, 3 over 4 times x power of negative 8 minus 1. Simplify, you get negative 8 times 3 over 4 is negative 6 times x power negative 9, so equals to negative 6. So by using law of indices, x power of 9. So negative 6 over x power of 9 is the dx for the function y equals to 3 over 4x to the power of 8. Okay, for example E, we are given y equals 2 over 5 times square root x. Actually, square root x is x power of 1 over 2. Find dy dx by using the same formula. Bring 1 over 2 in front, times with 2 over 5, and x power 1 over 2 minus 1. Simplify, you get 1 over 5, x power of negative 1 over 2, so equals to 1 over 5, x power 1 over 2, so equals to 1 over 5 square root. Okay, for example F, this one is you have two functions, so use to find dy dx for y equals to 5x cubed plus 3 over 4x over 4. So differentiate separately. So that means dy dx equals to, first differentiate 5x cubed, 3 bring in front, 5x, so 3 minus 1 plus this one 4 bring in front times 3 over 4 x power of 4 minus 1. And then simplify, you get 15 x square plus 3 x power of 3. Okay, for example G, the function is y equal to x minus 3 times x plus 2. So in this case, we have to simplify y first by expand. So you get x square plus 2x minus 3x minus 6. That means you get y equals to x square minus x minus 6. And then find dy dx equals to 2 bring in front, x, 2 minus 1, you get power of 1. This one, x power 1, you get 1, x 1 minus 1, so negative 6 when you differentiate you get 0 because 6 is a constant. So simplify, you get 2x minus x power 0 is 1, so you get 2x minus 1. So for example H, also same, you have to simplify y by expand x plus 3 square, you get x square plus 6x plus 9, and then find dy dx using the same formula. You get 2x the power minus 1, 2 minus 1 is 1, 6 times 1, 6, x the power 1 minus 1, 9 is constant, so you get 0. So simplify, you get 2x plus 6, x power 0 is 1. Okay, for example I, we are given y equals to 3x power 4 minus 4x squared plus 1 over x squared. So this one also you have to simplify y first. Separate 3x power 4 over x squared minus 4x squared over x squared plus 1 over x squared. Simplify again using law of indices, you get 3 x power of 2 minus, this one just cancel, x squared, so minus 4 plus this one, bring x square above, you get x power of negative 2, and then find dy over dx equals to 6, 2 times 3 times x, so 2 minus 1, you get power of 1, minus 4 is 0, so minus 0, when you differentiate 4, you get 0, plus, then negative 2 in front, x power negative 2 minus 1, so simply get 6x minus 2 x power of negative 3, and you can write 6x minus 2 over x